Good evening, sir.
Good evening, everyone. Good evening, everyone. Just in 1 minute, we are starting. Okay, let's continue. So we were doing carbon and its compounds, right? Let's continue with carbon and its compounds. So we had done. Okay, see.
Good evening, sir.
Yeah, good evening. So we had done covalent bonding in carbon. So Sumuk, what is a covalent bond?
A bond with single valency.
A bond with yeah, yeah. Speak up, Sumuk. What is
Sir, a bond forming H2,
a bond?
H2 atoms, two hydrogen atoms.
Anyone else? Can anyone else state? Abhinav?
I don't remember.
Okay. Shubhansh?
Sir, sharing of electrons.
Sharing of electrons. Very good. The bond formed by the sharing of electrons. There is no ion formation taking place. The bond between the two atoms is formed by the sharing of electrons. So here the bond is formed by the sharing of electrons. We call this bond to be a covalent bond. So out of the ionic bond and a covalent bond, which one is a stronger bond?
Hydrogen.
Ionic or covalent? Which one is a stronger bond?
Sir, covalent.
No, ionic bond is a stronger bond. Covalent bond is a weaker bond. Okay. Anyways, today we'll continue with allotropes of carbon, or we can want to do allotropy. So allotropy, it is the property. It is the property of an element to exist. It is the property of an element to exist in two or more physical forms. Okay. The property of an element to exist in two or more physical forms at the same time. Two or more physical forms under similar conditions. So this property is exhibited not only by carbon, but some other elements also. Some other elements also do show the property of allotropy. So which elements show apart from carbon? If you observe carbon, so we have two allotropes of carbon. The two allotropes of carbon, they are diamond and graphite. So you have diamond, which is an allotrope of carbon. Then you have graphite also. So diamond and graphite, they are the allotropes of carbon. There are allotropes of phosphorus also. So that means phosphorus also exists in more than two physical forms. Okay. So phosphorus exists as yellow phosphorus and red phosphorus. In the similar way, you also find the allotropes of sulfur. So the allotropes of sulfur, they are rhombic sulfur and monoclinic sulfur. Okay. So there are different elements which can show allotropy. So allotropy means the same element or the same substance, it exists in more than two or more than two physical forms under the similar conditions. Okay. So under the similar conditions only, you will find carbon existing as graphite also. You will find carbon existing as diamond also. Okay. So the properties are also different. If you observe graphite and diamond, can anyone tell me the differences between graphite and diamond? Yeah, Abhinav. Abhinav,
Yes, sir.
can you tell the differences between graphite and diamond?
Graphite is less harder than diamond.
Yeah, graphite is not hard, it's soft. Okay.
Diamond is more
Yeah, diamond is the
shiny.
hardest substance. So if you look for the properties of both of them, so I can list out a number of differences between diamond and graphite. So if I start listing, I can list out for diamond. So first of all, diamond, it's hard. Okay. Or you can say it is the hardest substance. Whereas graphite is not hard. It's not hard, it's breakable. Now, any other property, any other difference between graphite and diamond?
Um,
Yeah,
diamond
Sumu,
is
Subhansh, Subhan Singh.
Yes, sir.
Yeah, any differences between diamond and graphite?
Sir, graphite is a good conductor of electricity.
Okay. So graphite is a good conductor. See, both of them, they are made up of carbon only. Whereas diamond, it's a poor conductor of electricity. It does not conduct electricity, or it's an insulator. Any other differences you can think of between diamond and graphite?
So diamond may be shiny and graphite may not be.
Okay, so diamond is shiny, whereas graphite is the
a difference in the bond structure.
differences in their bond structure. Yes, so that which what we were looking for now. See, these are the physical differences which we observe between diamond and graphite. Now their bond structures or the structure of the diamond and the structure of the graphite will explain this property. So their structures will explain these properties, that how the diamond is so hard, whereas graphite is not hard. Okay, so Sumukh is asking difference between a bad conductor and a poor conductor. No difference, it's the same. Okay, just your English. So you can either use poor conductor or bad conductor, or you can also use the word insulator. Instead of saying poor conductor, you can also use the word insulator. Now let's see the structures of diamond and graphite. They will explain how the difference in properties is there. So see how the structure of diamond works. So for the diamond, See, we just observe in the covalent bonding that every carbon can share 4 electrons, right? Yes or no? Aryan,
Sir, can you repeat?
Sir,
how
could you
many
repeat, sir?
electrons can be shared by a carbon to form a covalent bond?
Sir, is it 2?
No. Siddhisri, how many electrons will be shared by carbon? Siddhisri,
Sir, 4 electrons.
4 electrons, definitely. The carbon has 4 electrons around it. Okay. So if we had drawn like this carbon and each carbon had 4 electrons around it. So every carbon has the capacity to share 4 electrons. See, if carbon shares 4 electrons, okay, so it will also receive 4 electrons and hence it will complete its octet. So something like this will happen. See, you have a carbon atom and each carbon is having 4 electrons. So if carbon will share 4 electrons, then it will also gain 4 electrons from other, okay? And then only the octet of carbon will be satisfied. That means then only there will be 8 electrons around carbon. Okay? So see, I have drawn here another carbon atom here, another here, and another here. Okay. So all these atoms of carbon, yeah. So see now. So all these are atoms of carbon, and each carbon has contributed one electron to this central carbon atom, and hence fulfilling its octet configuration. Okay. Now the central carbon atom has a total of 8 electrons, right? Okay, just give me 1 minute. Okay, see. So can you see the central carbon atom? It now
Yes,
has
sir.
8 electrons, right?
Sir, what
One
about
electron
the
each. Yeah, what happened?
carbon atom on the top?
What happened? Pardon?
Carbon atom at the top, sir, will it not have anything? Or
Carbon atom and
at the top one?
yeah, okay, sorry. The carbon atom at the top one, it has only 1 electron, right? So let me make it 4. Okay. So now it's correct. So
Yes.
now the central carbon atom, it has 8 electrons and hence its octet is satisfied. Now in the same way, if the carbon atoms are arranged in the same way, each carbon atom bonding to the next carbon atom, giving rise to a tetrahedral structure. So in this way, they are joined together to form a tetrahedral structure. So here they both join and such a structure is called as a tetrahedral structure. Okay, I'll tell you what a tetrahedral structure looks like. Okay, so here carbon joins with other carbon to form a tetrahedral structure. And when carbon joins in this way to form a tetrahedral structure with the other carbon atoms, this gives rise to the formation of diamond. This is the basic towards the formation of diamond. So diamond has tetrahedral structure of carbon. Each carbon bonded to other 3 carbon atoms with a tetrahedral, giving rise to a tetrahedral structure. So see how it looks. Okay, I show you a tetrahedral structure. So see, this is how a tetrahedral structure looks like. Okay. So the angle between all of them is the same. This is your tetrahedral structure. So in this way, diamond is formed. Your central atom here is carbon. So here the central carbon atom, this one, it is joined to the other 4 carbon atoms, giving rise to a tetrahedral shape. Here the angle between each of the bond is not 90 degree. The angle is 180. So this angle, this angle, this angle, this angle. Everywhere you'll find the angle to be 108 degree. So this is a tetrahedral structure. So when carbon combines in this way, it gives rise to a diamond. So somewhere, if you observe this structure, so you can observe the structure something like this also. See, if I give you the structure of diamond. Okay, see, this is how it looks like. Got it? The tetrahedral structure. Each carbon covalently bonded to 3 other carbon atoms or 4 other carbon atoms to obtain the tetrahedral structure. Okay. So this is the structure for diamond. We add this, the structure for diamond. See, what I observed here, you can see here as a small unit. So let me show this as a small unit. You can see here that this is a tetrahedral structure. Here, if you observe any one, so you will observe a tetrahedral structure. So everywhere, all the carbon are joined with the tetrahedral structure, and you can see that all the 4 electrons of carbon have been used in the bond formation. Got it? Yes. So carbon has used here all of its electrons for the bond formation. Okay, just 1 minute. कोई नहीं है. Okay. So got this? Everyone understood about the structure of the diamond? See here, each carbon, these circles, they represent, or these balls, they represent carbon, and the lines, they represent the bond between carbon and carbon. Okay. So hence it is a tetrahedral structure formed with a covalent bond. Got it? Yes, Sudhanshu, Siddharth, have you understood tetrahedral structure?
Yes, sir.
Okay. So see now, as you can see, there are no electrons available. All the 4 electrons have been used in the bond formation. So carbon cannot donate any electron for, there is no free electron with this carbon to conduct electricity. And hence, diamond is a poor conductor of electricity. So why diamond is a poor conductor of electricity?
Because there are no free electrons to move.
Yes. Okay, so why diamond is a poor conductor of electricity? So the reason here is that all 4 electrons of carbon are used in bond formation. Okay, hence no free electrons are available. Right. Now see what happens with graphite. So no free electrons are available for electricity to conduct. Also, this is a rigid structure. Okay, the bond formed with the covalent bond or the tetravalent covalent bond which is formed here. This is a rigid structure. Now let's say the structure for graphite. How does graphite work? So see now, for graphite, each carbon atom is now linked with only 3 other carbon atoms.
Sir, could you show the
Leaving,
previous page, sir?
okay,
Completed,
So
sir.
when are we going to get angles in this? In which class are we going to get angles?
yeah, what happened? Yeah,
Sir,
repeat your question.
in which class are we going to get angles between the bonds?
Angle between these bonds you will be studying in class 11. Okay, you will get to know about the bond angles. Right. So here, the next one is graphite. So for graphite, each of the carbon is joined to only 3 other carbon atoms. So here we have 1 carbon joined to other 3 carbon atoms only. And this gives rise to a hexagonal plate structure. Something like this. So in this way, it gives rise to a hexagonal plate structure. So see, I'll just draw how the hexagonal plate structure works here. So you have here one hexagon. So see, then another. So you will find each of the carbon being joined to only 3 other carbon atoms. So something like this it works. So if you observe the bond, what I haven't drawn the complete structure, but if you observe here, so see the bond formed by or the number of bonds formed by this carbon is 3. So this carbon is forming 3 bonds. This carbon is also forming 3 bonds. In the same way, this carbon is also forming 3 bonds. So all combines here. Got it. Again, you get it. Get it. Okay. So see, now every carbon is combined to 3 other carbon atoms. Got it? So can I say that one electron is still available or free? Yes. Since each carbon has
Yes, sir.
4 electrons, out of which 3 have been involved in the bond formation. Okay. So one electron is still there. So can I say that graphite will be a good conductor or graphite can conduct electricity?
Yes, sir.
Yes, Rizwana Sheikh, have you understood? Rizwana Sheikh, can you explain how can graphite conduct electricity, but diamond cannot? Yes, Rijwana Sheikh, am I audible? Sudhanshu? Sudhanshu? Siddhisri, am I audible? Dhriti?
Yes, sir.
Okay. So can you explain why graphite is a good conductor of electricity, but diamond is not?
So in graphite, in the bond formation, there are two electrons that are not participating in bond formation. So there are a number of free electrons. But in diamond, all the four electrons of carbon are used in bond formation. So free electrons are not available for the conduction of electricity.
Yes. Okay. So very good answer. Now, can anyone explain why diamond is a hard structure but graphite is not? Yes. See, for graphite, we have a layered structure. Layered structure means the hexagonal plates, they are arranged in the form of layers. Okay. So see how the hexagonal plates are arranged in the form of layers. I just show you for graphite. You see, this is how the structure of a graphite looks like. So in graphite, you observe that each carbon atom is bonded to carbon atoms in the form of hexagonal plates. And still, here also we observe four bonds, but one of the bond is a very weak bond. This one. So such a structure is represented by graphite. You can see here a top layer of hexagonal plates, each carbon atom combined to three other carbon atoms, another hexagonal plate here and another hexagonal plate. So this that difference in their structures gives rise to their difference in properties. Understood everyone, graphite and diamond? Yeah, Siddhisri, have you understood? Okay. Now, as I also talked of phosphorus and sulfur, so sulfur exists in two forms, monoclinic sulfur and rhombic sulfur, where 8 atoms of sulfur are joined together to form a molecule. Okay. And their way of arrangement gives rise to different properties. Dhriti?
Yes, sir.
So, can you name the allotropes of sulfur?
Sir, I don't know.
Hmm. Okay, see. So, yes. So, Sumukh has given the answer. Rhombic sulfur and monoclinic sulfur. They are the names of allotropes of sulfur. So, if you think allotropy of sulfur, so allotropes of sulfur are monoclinic and rhombic. Now, we start with another property, that is catenation. So, catenation, it is the self-linking property catenation is the self-linking property of atoms to form long chain bonds with itself. So, can an atom form a bond with itself? Of course, yes, we have seen oxygen forming a bond with oxygen. So, how do you think that their valencies are satisfied when one oxygen is bonding with another oxygen? Can anyone explain me the formation of oxygen molecule O2? Can anyone help me in understanding the structure of Cl2, chlorine? Okay, draw the electron dot structure of oxygen and show the bond formation for to obtain the oxygen molecule.
So both are monovalent, right?
Both are,
Monovalent, right?
no, they are divalent.
Oh, sorry.
See, oxygen has combined with another oxygen. See how it combines. Every oxygen has 6 electrons. Okay, so now when one oxygen combines with another oxygen, they must satisfy each other's valence. So either of the oxygen cannot donate the electron. Okay. If any one of them donates the electron, so there will be a lack of electrons on that oxygen, right? So what happens here? Each oxygen shares a pair of electrons. Okay. So one pair of electron will be shared by each of the oxygen to achieve the covalence. Yes. Yeah, very good. So these two electrons, they are shared. I can draw them here. So these two electrons, they are shared between them. Okay. So this line which I have drawn, it represents the bond. Okay. So one line means each atom has shared one electron. So a total of 2 electrons have been shared. Okay. And here in this one, there are 2 bonds. So that means a total of 4 electrons have been shared. Got it? In the same way, we can see the structure of chlorine also. So structure of chlorine, it can be written as Cl, each chlorine having 7 electrons. So 1, 2, 3, 4, 5, 6, 7. Then 1, 1, 2, 3, 4, 5, 6, 7. Yeah. So each chlorine having 7 electrons now will share just 1 electron with each other to complete their octet. So we are discussing a catenation. See, why oxygen has combined only one oxygen? Can it happen something like this also for oxygen? Can we have like this? Like each oxygen sharing one electron like this and forming a long chain. See, every oxygen's valence is now satisfied. So, is it possible for oxygen to have like this? A long chain of oxygen?
No, sir.
No. Okay. So, this property is shown only by carbon. This property is called as catenation. If I do it like this, so I am wrong. Oxygen cannot do this. It can be shown by carbon. This property is called as catenation. So yeah, it is possible with carbon. It can form carbon, 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 so on. Again carbon, again carbon, again carbon, so on. It can move on infinite. Okay. So about millions of carbon atoms can be joined in a single chain. Okay. So this special property of carbon is called as catenation. This property is not available with any other. Only other element that can show this property is silicon with just up to 4 atoms. silicon, which is similar to carbon. So silicon can show this property just up to 4. Silicon, 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 and silicon. Only 4 atoms of silicon can be joined together, not more than that. So catenation is the self-linking property of atoms to form their, to satisfy their configuration. Got it? Okay. So by all of you, today we have done the topic catenation, and we have done these 2 topics. We have done catenation and allotrophy.
Allotrophy.
Okay. Okay, bye all of you.
Thank you, sir. Bye, sir.
Thank you, sir.